In this video, we're going to talk a little bit about definitions. That way we all have the same basic understanding behind it, so that way when we're all talking to one another, it really won't be a problem, or hopefully. Eventually you'll get used to the whole idea of this vocabulary. Now, mathematics is very exacting, so be very, very careful on how you use the vocabulary. There is no synonyms, there's no antonyms, they're just isonyms. And so, here we go. Some definitions. So for instance, a set. A set is a collection of objects or numbers. I just call them things and stuff. But basically, think of a set as a box. And so you have a set of things here and you can count them and you can organize them and that sort of thing. And that's a set of things. And we denote a set by using a brace. And the braces, if you're on your keyboard, they can actually be found just above and to the left of the Enter key. And that's for a common Microsoft keyboard. Apple probably located in the same place. They really don't want to change things too much. And your brackets are also there, but your braces are Shift and those buttons, or probably the Command key and those buttons. Well, no, this is a Shift key, and Apple isn't there. So we have these little braces, and there's a set of items in here. Set of things. Okay, that's what a set is. Now, if you're in a set, you can have a couple of different types of sets. One is you just have a finite set, meaning that there's a countable number of things inside. So you might have, for instance, triangles that have an area of less than 20 that are also Pythagorean triples. I'm just throwing stuff out there. But there's a finite number of those triangles, and so we can list them. Same as using the numbers 1, 2, and 3. We just simply list them out. That's how we define. Or if it's a really, really long set, you don't list it, but you might create some kind of a definition, or like I did with the triangles that have Pythagorean triples and also have an area of less than 20. I can just put that definition or that description in there, and that will include the set that I want to include. The next way to do it is if you have an infinite set, meaning there's lots of stuff. In fact, there's so many things that it just never quits. 1, 2, 3, if you were to just sit there and count forever and ever and ever and ever, you would never end. There's always another number in the counting set. And so we say, well, this is an infinite set, and these 3 dots are used to say that pattern just goes on and never stops. Okay. Now, if I had there's another way to use these ellipses as in these finite sets, and you could use them, for example, if I want to say all integers from 1 to, I don't know, we'll call it 1 million. All right, so this amounts to, back when you were a kid, of 1, 2, skip a few, 99, 100. And we can use these ellipses to say, continue this particular pattern, but continue it up until you hit 1 million. And that's another way of saying, oh, I just skip a bunch in there. You don't really skip it, they're there, but we've already kind of established the rule and it's going to take me way too long to list them individually. So that's another way you can use the ellipses. Variables. Variables are things that represent quantities or other numbers. Now, they can't be a number because then they would be absolute and you wouldn't be able to change the value of it. But they don't have to be letters. Now, when we're studying algebra, that's when we're going to use letters, but it's not necessary. In fact, you might remember doing problems like this where it says 3 plus what is equal to 7. You say, oh, well, the answer is 4. Yeah, except that the box was a variable. You didn't know that, did you? Okay, it's just it is a non-number that represents a number. Now, the thing about variables is you don't know the value of it necessarily, and it can change depending on the problem. Hence, it varies. Variable. All right, a couple more things here, we'll be done. Absolute value. In short, this is the distance between whatever's inside and the number 0. If you express it in a slightly different way, let's say 3 minus -4, we put all that mess in parentheses in absolute value signs, then what that means is we're looking for the distance between 3 and -4. Now, in this case, the negative sign or the minus sign always has to be there if you want to describe the distance between these two numbers. And so the distance between 3 and -4 is 7. Well, if you take inside, if you use the absolute values just like parentheses and say, well, let's do the inside first, then you ask yourself, well, what is 3 minus -4? That's a positive 7. And the absolute value of a number is the number if whatever's inside is greater than or equal to 0. However, you take the opposite of the number if that number is less than 0. So you have the absolute value of 3 using the top is 3, but the absolute value of -3 using the bottom is the opposite of -3, which is 3. It's still positive. Absolute value is always positive. Always. It can never be negative, ever, for any reason. It's going to try to trick you. There will be questions like that. Don't listen to them. It's always positive. All right. So we take the real number line. And the real number line just provides us kind of a visual guide to what's going on. There's no need for it. It's not necessary, but it gives order to everything. So we use the number line to kind of visualize what's happening between numbers, what kinds of things can be included, whether or not we can use things in between integers, that sort of thing, and it just describes the situation. So graphing on it is not that bad. If you wanted to graph, say, the set 1/2, -5, 0, and 2, then you could simply use that. And I'll do it in white here. And so we put a solid dot at 1/2. Do not use an open dot. That means something different. But we put a solid dot at 1/2. We put a solid dot at -5. We put a solid dot at 0. And we put a solid dot at 2. Okay, so that's just a way to graph a set of numbers on the number line. We're using real numbers. I'm not going to tell you what other things are out there quite yet, but there are other numbers out there than real numbers. They are not called fake numbers, by the way. A coordinate is simply a point on the number line, and so it's a value for that particular variable. Later on, we'll say, okay, well, what happens if we have a number line that goes this way and a number line that goes this way? And then we can go to the coordinate plane, which means we have two coordinates, a this coordinate and a this coordinate. And we can describe any point on that plane based on those coordinates, much like latitude and longitude on the Earth. All right? These are just some simple definitions to kind of get used to, but we're going to need to know them, because when we start talking about them, or if you're discussing them with somebody else that speaks math, you got to speak the language. Otherwise, you guys will be running around in circles.